Welcome and thank you for taking an interest in studying physics at A Level. So first of all, let's start with a bit of a course overview. What's lovely about the Physics A Level is it's split into modules, and lots of the modules very much revisit and build on and delve deeper into some of the topics you've seen before at GCSE. For example, the motion section here. Lots of this has been already visited at the GCSE. Some of the distance time graphs, for example, velocity time graphs, some basic stuff on stopping distances. So what this module does is very much take what you have there, recap it, build on it, delve a bit deeper and go a bit more behind sort of the actual science behind the theories you learnt for your Year 11 exams. Likewise, forces in action. So there's some new sections in there. Some of the work on terminal velocity, some of the work on moments and torques will be beyond what you've done at GCSE, but some of the force basics, mass, weight, etc. it's pretty much exactly what you did at the GCSE level. Likewise, within the work energy power, again, there's some new elements in there. We have to be a bit more careful how we use some of the terminology at A level, and what they get you to do in terms of the questions is a bit more challenging, but the basic physics of work and power and kinetic and potential energy is still exactly the same. There's some new stuff in there, so some new stuff in the materials. Circuits and electricity, of course, you've met before. This goes into a lot more detail at the A level. If anything, it sort of gives a greater understanding because you've got a lot more detail as to what's physically happening and the rules behind some of these behaviours, as opposed to just at GCSE where you're having to accept some of the rules. Waves, again, you've seen a lot of waves before. Quite a bit of new stuff in the wave section, but again, goes into a bit more detail, bit more deeper understanding, and actually makes some of the wave stuff that you're learning now slightly easier to understand. And then the quantum physics, pretty much all new. There won't have been much at the quantum physics you'd have come across before. So that's year one. That includes some required practical elements and practical skills in there as well. And that is what's studied in the first year of A level. Then we move on to the second year of study. So the second year course revisits and again builds on what you've already learnt and goes into some more sort of new interesting topics. So the thermal physics, there's tiny elements of that you'd have seen before, but a lot of that's new. Circular motion and simple harmonic motion are building on the mechanics you've already learnt, so that's further advanced mechanics. Gravitational fields, lovely new topic. The astrophysics and cosmology, really interesting stuff in there. Capacitors is a whole sort of circuit section on its own, which sort of builds on the circuit work from year one. Electric fields, electromagnetism. Again, you've seen some of this at GCSE, but not too much. And then the nuclear and particle physics starts GCSE level where you sort of already know, sort of basic atomic structure of the nucleus, and then delves a lot deeper and goes into a lot more detail, much more interesting and sort of full of the explanations that kind of back up what you're trying to learn at GCSE. And then there's a section here on medical imaging, so looking at x-rays and other types of imaging such as ultrasound and so on. Again, there's a bunch of required practicals in the A-level course in the second year. Complete those as we go through within the topics. And then the end-of-year exams at the end of year 13 are split into sections and they cover the content from both years 1 and 2. So, key skills of a physicist. Lots and lots of skills needed to study physics, but also skills developed whilst you're studying. So the problem solving is a huge aspect, really useful in terms of being given a situation, identifying what the relevant physics is, digging down into it and being able to use that to work something out. That's where the reasoning comes in. A little bit of research and data skills in there. Key thing there is the analysis. That's the key element and the sort of the key skill that's learnt there. Obvious numeracy skills, equation manipulation, graphs, etc. The practical skills, we have the required practicals throughout the 2 years. Those are designed to develop different skills within the practical requirements. And as you can see here, there's also communication, team working, time management, and information technology. So we use data loggers and other sort of software within the work that we do. All of this makes you incredibly employable. So physics is a much sought after qualification because employers know that it means you have a certain set of skills and you have a wide ranging set of skills that not everyone has. So this is from a Institute of Physics website, but it gives some examples of where people with physics related degrees tend to end up. So anything from aerospace and defence into education, energy and engineering. Health and medicine, there's a whole section of medical physics in terms of sort of radiotherapy, gamma knife surgery, etc. So that's kind of an area that's sort of getting bigger and has more employment opportunities. Manufacturing, climate change, nanotechnology, science and telecommunications. And then less obviously, lots of people with physics qualifications are heading into areas like banking, finance, computing, consultancy, law. And this is all because the wide range of skills that you have or have demonstrated by getting a Physics A level make you very, very sought after. You're very employable, you can deal with lots of different situations, and it just shows that you've got a certain way of thinking and dealing with things which employers like. Entry requirements then. So we need at least a grade 7 in GCSE physics, or if you're doing the combined science version, at least a grade 7/7. We also need a grade 7 in GCSE mathematics as well. So following on from that, we get asked some fairly regular questions, and one of them relates to the maths. So very often we get asked, do you have to study maths A level if you're doing physics A level? And the short answer is no, you don't. The maths we need, we teach as we go along. So if you're not doing maths A level, you're still, if you've got the 7 or higher in the maths GCSE, you'll still be absolutely fine to do physics A level. Obviously, if you are studying the maths, you have the advantage that you're practicing using it a lot more often, and you'll also be in the maths A level doing maths at a higher level than some of the A level physics maths requirements. So again, it just gives you a slight advantage, but you can absolutely study physics without studying maths. A word of caution there, if you're looking at going on to do something at university that's anything sort of physics, engineering, or sort of maths, or even computing related, they would tend to want you to have a maths A level as well. And it's always worth trying some university websites and just looking at their entry requirements and seeing what A levels they list as essential and what A levels they list as sort of desired. If you want to study physics at university, you will need maths A level, and for some universities they also like you to have further maths as well for some of the top universities. So some of the Oxford and Cambridge colleges, for example, they want the further maths, and the physics. Another question we get asked often is, I hear physics is a really hard A level, and my answer to that is always, well, yes, but no harder than any other A level. The jump from GCSE to A level is always tricky. It is a big jump, and all A levels are difficult. I guess the slight difference with physics is it doesn't ease in so much, so you tend to start off quite hard level at the beginning, but that's maintained throughout the course, and actually the way the modular content is laid out means that you get better at dealing with the sorts of questions, the situations, and you develop those skills, but all the new content is only at the same level as the previous content. So over the 2 years, it doesn't really get any more difficult, whereas some subjects maybe start slightly easier and get gradually harder as they go through. What physics does have, of course, is the reputation for being difficult, so it gives you a slight edge on paper if you've got a physics A level, if you're in competition with someone who maybe has a different A level. Another question we're frequently asked is, who will be my teacher? So where the timetable allows at NGHS, we have all of the physics departments teaching different elements of the A level, so you'll get a different teacher for different sections of it, which seems to work really well. It also means you've got 3 different teachers you can go to if you're stuck at any point, and there's always someone you can get help from. So finally, why study physics? Well, if you have an inquisitive mind, you like knowing why things happen rather than just being told that they do, you like to get a bit deeper into what's going on in a situation, then physics is definitely a subject you'd be interested in. Physics also helps you develop a really desirable set of skills for whatever you want to go on to do in the future. So if you've got a physics A level on your qualifications list, it always looks impressive and never does anyone any harm when they come to applying for future courses, qualifications or jobs, etc. And finally, if you enjoyed aspects of the physics GCSE, then you'll definitely enjoy getting your teeth into the deeper and more fulfilling aspects of the physics A-level course. If you have any further questions or want to get a bit more detail, then email the school, mark it for the attention of the head of physics, and I'll do my best to get back to you as soon as I can. Thanks for listening.